So this problem says that a block slides along a rough surface and is brought to rest after traveling a distance of 2.4 meters. The frictional force is assumed constant at 3.2 newtons, and calculate the work done by the frictional force. So if we think about this situation, we have our surface that has friction on it. And what we have is we have an object that is initially moving here, so it's going to have some kinetic energy, and then it's going to be brought to rest here. And so, we have some initial velocity. Let me write it this way. We have an initial velocity which is greater than 0, and then our final velocity is equal to 0. And that happens in 2.4 meters. Now, what's going to happen is we have a frictional force acting backwards, and that is a value of 3.2 newtons. And so, if you look at this, we have kinetic energy. This frictional force is going against the direction of the motion, and so we're going to have some acceleration in the negative direction, right? If we're going to say that to the right is in the positive direction, that's the positive x, and then that's my positive y. The block is moving in the positive x, it is slowing down, so my acceleration must be in the negative, and so my frictional force, which is really would be my net force here, would be in the negative direction as well, right? You'd also have, a gravitational force and the normal force. Those two would cancel each other out, and so really the only force that we're dealing with is my frictional force. So in this case, it asks us to calculate the work done by the frictional force. And our equation is going to be that work equals force times displacement cosine theta. Now, if we think about this, here's my object again, right? My force is in the negative direction. My displacement is going to be in the positive direction. That's the direction that it's moving. And so the angle between these is going to be 180 degrees. So when I'm plugging things into this equation to calculate for my work, my force is 3.2 newtons. The displacement is 2.4 newtons. And then the cosine of 180. And this is going to be a value of -1. When we combine all those values, we're going to get that our work is going to equal 7.68 Newton meters. And that's actually a negative 7.68. So negative 7.68 Newton meters. And really the negative work indicates, so a negative work indicates that we're going to lose kinetic energy in our system. And so we start with some value that has kinetic energy. This object then without motion is going to have 0 kinetic energy. So we're losing 7.68 joules of energy, and that's because the friction is doing -7.68 Newton meters of work.